Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, in last lecture we have discussed about what is equilibrium of rigid body and couple. Yes, today we will see one important topic which is called principle of moments. What is principle of moments and what is lever mechanism? See, lever mechanism. What is lever mechanism and why it is used? See, this lever mechanism is used in many applications. Okay, so what is lever mechanism? What is its use? What is equation? That we will see. Actually, lever means what? What is lever? It is lever is a system of a rod pivoted at a point called fulcrum. Okay, what is lever? Lever is a system of a rod of negligible mass pivoted at a point which is called fulcrum, like this. See, it is one rod. Okay, if it is pivoted at this point, so it is called fulcrum. It is called fulcrum. Clear about this? So yes, system of a rod which is pivoted at a point, okay, called fulcrum, is called lever. So this system is called lever. Okay, in yes, playground, if you have observed seesaw in children's garden, okay, so that seesaw is example of lever mechanism. That seesaw is example of lever mechanism. Okay, so yes, it is lever mechanism. In this lever mechanism, let two parallel forces are acting. Let it is F1 and let it is F2. Two parallel forces are acting, F1 and F2, and these two forces are perpendicular to length of lever. So let, as shown in figure, two forces F1 and F2 are acting at two ends. Let from this fulcrum distance of this force is given and distance of this force is given. Okay, from this fulcrum this force F1 is acting at distance given. From this fulcrum this force F2 is acting at distance d2. So let, as shown in figure, two forces F1 and F2 are acting at two ends at distances d1 and d2 from fulcrum. Okay. Now see, this F1 and F2, these two forces are parallel to each other and perpendicular to length. Two forces are parallel to each other. They are parallel to each other and perpendicular to length of rod. Clear about this? So yes, it is one system which is called lever mechanism. Okay, two forces F1 and F2 parallel, it is called fulcrum. Okay, see, now this lever, it is in mechanical equilibrium. This lever mechanism, the lever mechanism is in mechanical equilibrium. Now, what is meaning of mechanical equilibrium? That we have discussed. If system is said to be in mechanical equilibrium, means it is in translational equilibrium. and also in rotational equilibrium. Again, if system is in mechanical equilibrium, it means it is in translational equilibrium and also in rotational equilibrium. So first of all, I will write for translational equilibrium. See, for translational equilibrium, what is condition for translational equilibrium? Okay, sigma F is equal to 0. Okay, total force sigma F is equal to 0. Here in this system, there are two forces, F1 and F2, and see, they are acting in same direction. So is it possible that sigma F becomes 0? No. There must be another force which acts in opposite direction, and yes, that force is here. As this rod is pivoted at this fulcrum, due to this fulcrum, reaction forces acting in this direction. Why in upward direction? Because if this R is in opposite direction of F1 and F2, then sigma F is equal to 0 is possible. Clear about this? So at fulcrum, reaction force is acting in opposite direction of F1 and F2. Okay, because if it is acting in upward direction, then their addition is 0. It is possible. Clear about it? So yes, for this, now for translational equilibrium, how to write? Okay, yes, for translational equilibrium, how to write? Okay, yes, sigma F is equal to 0. So see, there are three forces in this system, F1, F2 and R. Out of this, F1 and F2, they are in downward direction, while R, it is in upward direction. So how to write this? Yes, if I am taking downward direction as positive and upward direction as negative, then I can write F1 plus F2 minus R is equal to 0. Equation number 1. Or simply, if you want to write, then you can also write F1 plus F2 is equal to R. Simple. Okay, it is for translational equilibrium. Clear about this? Now, as the lever mechanism is in mechanical equilibrium, it is also in rotational equilibrium, and for rotational equilibrium, we have to consider torque. And torque with respect to this fulcrum, because in seesaw, yes, that seesaw will perform rotational motion about that pivoted point, fulcrum. Yes or no? Here, this lever mechanism will perform rotational motion about this fulcrum. Okay, so yes, we have to now take rotational equilibrium. For rotational equilibrium, we have to take torque. Torque means force into perpendicular distance. We have three forces, F1, F2 and R. See, R, its line of action is passing from this fulcrum. So due to this R, no torque is produced. Simple. Line of action of this reaction force is passing from this fulcrum. So due to this R, no torque is produced because no perpendicular distance. For this F1, yes, from this fulcrum, what is perpendicular distance of F1? It is d1. So what is torque produced due to this force F1? So the force into distance F1 d1. Similarly, line of action of F2, it is here. Perpendicular distance of F2 from fulcrum, it is d2. So what is distance between them? d2. So for this force, what is torque produced? It is F2 d2. For R, no torque. Due to F1, what is torque? F1 into d1. Due to this force, F2 into d2. But torque is vector quantity. What is direction of torque? See what happens here. About this point, due to this force F2, this lever mechanism will rotate in this direction. Yes or no? Yes it is. Yes or no? Yes it is. Okay, if it is pivoted point, fulcrum, okay, and if I am applying force, so see, it will rotate in this direction. Clear about this? It will rotate in this direction. Okay. Similarly, for this force F1, okay, if force F1 is applied, so see, it will rotate in this direction. Yes or no? So this hand will rotate in this direction. Now it is called clockwise direction and it is called anti-clockwise. It is called clockwise direction and it is called anti-clockwise direction. So yes, these two directions are opposite. So yes, one you have to consider and another you have to consider positive. One you have to consider positive and another you have to consider negative. If you are taking clockwise as positive, then you have to consider anti-clockwise as negative. Clear about this? Clear about this? Then how to write? See, here it is. How to write? Okay. See, now for rotational equilibrium, for rotational equilibrium, sigma tau is equal to 0. Sigma tau is equal to 0. Due to this r, there is no torque. So r into 0. Why? Because its perpendicular distance is 0. Now, what is torque due to F1? It is F1 d1. I have considered it positive in clockwise, F2. Yes, I can also write it as F2. Then I have considered F2 d2 as positive because it is in clockwise direction. So I have to take minus F1 d1. Why minus F1 d1? Because it is in opposite direction. So yes, here we have to mention, okay, let moment of force in clockwise direction is positive. Moment of force in clockwise direction is positive, and moment of force in anti-clockwise direction is negative. So yes, you can easily understand from this. Okay, due to this F2 force, moment of force, it is in clockwise direction. That's why I have considered it positively. Okay, F2 d2. See, here it is again. Due to this force, moment of force, it is in clockwise direction. So I have considered it positively. While for this, I have considered it negative. Clear about this? So yes, you have to take care when you write this equation. Okay, R0. Why R0? Because this reaction force, its line of action passes from fulcrum itself. F2 d2, that is torque. F1 d1, it is also torque. It is positive and it is negative. So yes, from this you can write, okay, F2 d2 is equal to F1 d1. It is F1 d1. That it is equation number 1. Clear about this? So yes, F2 d2 is equal to F1 d1. Now what is F1? F1 is considered as a load which we want to be lift. Okay, F1 is called load, while F2 is called effort. What is D1? D1 is distance of F1 from fulcrum. Okay, so D1 is called load arm. While D2 is called effort arm. Okay, so yes, F1 is called load, D1 load arm, F2 effort, D2 effort arm. Clear about this? Okay, so this equation, how to write this equation? Okay, that is effort into effort arm is equal to load into load arm. Load into load arm. And this equation is called, it is called principle of moments. It is called principle of moments. Clear about this? So yes, this whole theory you have to remember. Now what is use of this? Okay, sir, F2 D2 is equal to F1 D1. So now what is use of this? Okay, we will see this by taking one example. See here. Okay, see what is equation? Equation is F1 D1 is equal to, it is F2 D2. Load into load arm is equal to effort into effort arm, or you can also write this equation as F1 upon F2 is equal to, it is D2 upon D1. D2 upon D1. Also, this F1 upon F2 is equal to capital M dot A. Now what is capital dot M? It is called mechanical advantage. It is called mechanical advantage. Okay, now what is use of this mechanical advantage? See, I will draw figure again. If it is fulcrum F1, F2, distance of F1 from fulcrum or load, it is called load arm, and it is called effort arm. D. Clear about this? Okay, it is fulcrum. It is fulcrum. Okay, now I am taking some values for example. See here, F1 upon F2 is equal to D2 upon D1. F1 upon F2 is equal to D2 upon D1 is equal to mechanical advantage. Is equal to mechanical advantage. I am taking some values. If F1 is equal to 100 Newton, means I want to lift 100 Newton weight. Okay, let D1 is equal to 10 meter. From figure it is clear that D2 is equal to, it is greater than D1. So if I am taking, for example, D2, then yes, D2 is equal to, for example, it is 20 meter. 20 meter. Then what is effort? That is F. From this equation, make F2 as subject. So F2 is equal to, it is F1 D1 upon D2. What is F1? It is 100. What is D1? It is 10. Divided by, what is D2? Yes, it is 20. It is 20. Okay, so 0, 0. It is 2, it is 50. So it is 50 Newton. What is F2? It is 50 Newton. What is load? It is 100 Newton. So it is used. See, it is use of lever mechanism. Okay, if you want to lift object having weight of 100 Newton, you have to apply force only 50 Newton. But when effort arm is greater than load arm, okay, if effort arm is greater than load arm, or mechanical advantage is greater than 1, we can lift heavy object with small effort. We can lift heavy object, or you can say heavy load with small effort. And yes, it is use of lever mechanism. Now you can understand different instruments in which load arm is greater than, effort arm is greater than load arm. Clear about this? So yes, it is one theory which is related to equilibrium, mechanical equilibrium, translational equilibrium, rotational equilibrium. And actually what is lever mechanism, that you have to understand. Okay, so yes, what is use of lever mechanism? If effort arm is greater than load arm, with small effort, we have proved, okay, with small effort you can lift heavy objects, you can lift a heavy load. Clear about this? So yes, it is one theory, that is important theory of this chapter. Clear about this? This is it for today.